Hello, everyone. This is the first time I've done a virtual conference with so many people that I can't see their reactions, and since I make jokes and stuff, it's really hard for me. And here I'm also with Michał. Say hello.
Hi, everyone.
So he was also on this project, and today we're going to talk about Elixir at a bank. I guess the angle we have. We'll show you the slides. Got a lot of slides to get through. So I'm going to go fast, but I assume at some point this will be a video so you can pause and look at the details. So, and just shoot some questions in chat during the talk if you want, and then we'll try to get to them. I'll try to leave a few minutes at the end for questions. Okay, let's go full. There we go. So taking Elixir live at a bank. So just a quick introduction about OP, or Osuuspankki as we call it in Finnish. We're actually here in Oulu, which is pretty close to the Arctic Circle. It's just a little bit above us here. We are a sort of a traditional bank. There's 12,000 employees here, and we have 2 million customers, which is about half the population of Finland. So we have existed for over 100 years as a bank in Finland. So I guess when you want to look for the definition of a traditional sort of bank, you've got one here. And we have what we call branches or group companies. So every little bank is actually part of a larger group, and it makes our infrastructure super interesting. Okay. So we actually are part of a thing called OP Lab, and OP Lab is what we call sort of an internal startup, or it's a group that is doing more experimental and future type projects. We are here to keep OP as a group competitive and to see if there's any capability gaps and what's coming in the future. So, and of course, the face payments is one of these projects we've done. Just if you're not familiar with banking and how it might be different from what you're used to, or maybe in some other companies, and this is mainly at a more of a larger, more traditional type banking setting. We have things like audits, and this means it's not just somebody else at your company. It may even be an external third party who has to go through every detail of your code, every security aspect of your code, try to break your code. It can be an interesting process. Sometimes, actually, for most projects, when we go production, developers are told they cannot even go in and look at the system. So because we're dealing with customer data, a lot of it's sensitive. The actual production running systems have a very careful process of how to access them and who gets to access them, and even an audit trail of every single piece of data that was looked at and by whom. We also have of course, a large legal group. We pay a lot of attention to GDPR and these types of things. One of the things about this is it goes down to documenting every single field of data we have about a user. We have to justify why we have it and who has access to it. And it may be a separate team. I mean, a separate team shows up at your door and says, oh, you're launching a cool new project called Face Payments. What are you doing with this piece of user information? And you have to know it. Stability, these types of systems may have to run for decades, so it has to be super stable. Third-party stuff, whenever we include something from a third party, a library or anything else, there's a whole different group here actually that's looking at it and trying to analyze, is it okay to use? Are the licenses okay? Is there, is it good code? Scalability, because we have a couple million customers. Depending on the project, you could go live from day one with 1 million customers. So depends. In this case, we didn't do that, and things vary from off-peak. Around Christmas time, you may see 10 or 100 times the normal volume in something like transactions. Portability, also another thing a lot of people don't know, is that a lot of countries in Europe have even regulation that says, on the core banking systems, we may not be able to be locked into certain, to vendors, and we have to preserve portability just because banking is even seen as sort of a national security issue sometimes. So even during this pandemic, the banks have had to stay open, and it's super important that we maintain that. So just a quick slide here I drew to give you an environment. The way a lot of these traditional banks are built is that there's a lot of these, you know, at the bottom you'll find big mainframe type systems. They might be running COBOL and CICS and on IBM, and they're very much, they can be very old. 10, 20, 30 is quite possible. And then, you know, then usually there's a middle layer, which is where we put business processes and things like how do you bring in a new customer? How does the customer open an account? How do you check their credit? All of these things are business processes. Then you have things like business process management tools. And this layer, you see a lot of Java. Actually, in banking and this type of banking, it is like Java everywhere. And it's kind of the standard. You will find Go and C# and some other things used in places. And even down in the core nowadays, there's a couple of new banks that are starting out with the core banking features, which are things like transactions between accounts, have been done in, for example, Go and in Java. So there are some exceptions. And as you go farther up and farther up, there's more and more choices. It's much easier to use new things farther up in the stack. These are user experiences or digital experience platform. So you see Node and you see serverless stuff and C# and a lot of other things. You also see Java as well here a lot. And then of course the front end. So all I'm trying to illustrate here is that the deeper you go into this stack, the more you're facing standardization and the more you're facing all of these requirements. The farther you go up, sort of the looser it gets. Any questions there? So here's our face payment thing. It's in production. It's only in Finland right now. It's in some coffee shops. You can buy coffee. We are working on expanding it. I can't tell you all the details, but I can show you a quick video. So let's see, switch over to, share Safari. I hope you can see this video okay. If you can't, can you see it there? Okay, yep. Let's let it roll.
Moi.
Moikka.
No, pikkainen kahvi.
Tuleeko muuta?
Ei tarvi.
No niin,
Kiitos.
kiitos. Hyvää päivän jatkoa.
Samoin.
So, okay, getting back to the slides. That was a quick demo of what it is. Basically, it's a biometric form of payment. The idea here is that you just go and show up and pay with your face. It's pretty much exactly what the label is there. It sounds simple enough, but it's actually a lot more complicated than that. If I can skip forward here. So, you know, when we first looked at this project, we started looking at the requirements, and we said, okay, we're going to design this face payment system. I'll show you the requirements in just a second, but it's got to have mobile phones, because actually these are used to register, and these are things you interact with as a user. You get your push notifications there. If we need a second factor identification, we use that. The tablets that run at the coffee shop are the things the users interact with. Oh, and by the way, we have a new version where you don't have to touch the screen, because in COVID times, people don't want to touch anything anymore. So we're working on touchless, having a touchless version, which is all going to work automatically. And then we also have cash registers over here. So you have to punch in the amount, what the user, we haven't automated the recognize the product part of that yet, although we have thought of it. So And we also have integration to payment gateways, integration. We don't do the recognition ourselves. We use a recognition provider. So it's somebody we call out to, actually multiple ones we can use. And then we have a whole pipeline of things that you need to do, clean and liveliness. Is it a real person? Are they alive? Or are they just a mask or somebody trying to spoof the system? So when we looked at all this, we said, oh, lots of connections, lots of things to control, lots of scalability. This is something that would be good for Elixir, we think. So mobile phones, tablets, cash registers, payment providers, recognition services, image pipelines, all that stuff. So we got our requirements. The pipeline had to be end-to-end less than 3 seconds. And the reason for this is that NFC, if you just do contactless payment, it's pretty fast. I mean, if you pull out your card or your phone, you can do it in about 2 or 3 seconds. So we wanted to compete with a contactless payment systems. In order to do that, we figured we had to be around 3 seconds for the detection, and that was super important. And that's actually a really hard thing to do. We also needed to support multiple factors, meaning if the image recognition is not good enough, what do we fall back on? QR codes in this case. We had to be checking for liveliness because we're actually exchanging money. So we had to make sure it's a real person and not a picture of someone, like a spoof attempt. Mobile clients, point of sale terminals, PSD2 compliance, which is another interesting requirement, meaning the credit card company needs to have the ability to reject a payment and ask for further identification. The ask was for us to do this in 3 months with 3 people. Okay, I said that's impossible. It's going to take it'll take 6 months probably if we're lucky, even though it's impossible. But then again, nobody asked us, how are you going to implement this? Because it's like, I don't think they thought we'd ever succeed in this. So here's a quick infographic. Of course, these are all my own drawings here. So users over here, they actually download the application. Face payments for Pivo is actually the name. They enter their credit card, they register their face. And when they're registering their face, it's actually talking to our biometrics backend, which is talking to the recognition provider up there. Then they travel over to the coffee shop. Person punches in you got a coffee, it's €2 or €3. It goes to the cloud and through our server down to the tablet. The recognition is coming this way up to our biometrics. All this stuff is going on to make it happen. So like I said, when you play this video back, you can pause on the screen. Elixir. So these are, this is where we're going to use Elixir. So the fun thing about Elixir, when I was making this slide, I was thinking, what are you smoking or drinking in this case, the Elixir? Because when you talk to people about Elixir, you say things like, let it crash. That'll make your code safer. Or, there's no loops. Don't worry about it. And, our exception handlers are a code smell. Or it's functional, but it's still very easy to learn. And, it is powering the most reliable system in the world, the most reliable systems in the world, but, at the same time, it doesn't have static types. So, then is it microservices? No, it's a micro monolith. It's like, what the heck is a micro monolith? And why could you claim that it's a sort of microservice thing, even though you have a big server with lots of things running in it, a service? So, and then you might say things like, you don't need Docker or Redis or Nginx. Those things are all extra, And so, yeah, people kind of ask you what you're drinking. And we're drinking Elixir. So this is my kind of some of the feedback you get sometimes. How can that be practical? How will that be mainstream? Is that just for propeller heads? So I'm going to go through a few slides very quickly, which are about some theory, and then we'll get to our experiences. So some theory. This, if you're interested, I've got a blog here online if you want to read this, but it was about my journey, sort of personal journey to finding Elixir. And really, it started sort of in Rails, which a lot of you guys, and I know a lot of people using Elixir, did start out as well. So this kind of journey might be familiar. You're looking for a way to build very reliable, secure, scalable, and simple services. And, you know, I heard about Elixir and I was like, yeah, but, you know, I don't know. And so I started around this, you know, and tried to use celluloid, which was like an akka thing in Java with in Ruby with JRuby. And I worked on Spring for a while, and it was like, wow, so much code. And, you know, Go was cool, and we use Go. A lot of people like Go, but at the same time, I was looking for something more, and there was just so much error handling in the code, and wasn't really happy with the threading model. It's getting better though. Closure, nice. Scala, I don't know if you know a lot of that Scala actually, when it was designed, it was partially modeled after Erlang, and has a lot of the functional ideas from Erlang. Play, I got into Play. I could talk for an hour about Play and kind of what happens when you mix both threaded and blocking stuff with reactive type of non-blocking stuff. So you've got a mix of sharing threaded models in Play, and then, you know, people are like, oh, let's use Akka in Java, which is a copy of course, the actor model in Erlang. And so at the end of the day, you know, you just like, you can get to Elixir, take the shortcut. No, you don't have to, you can do this whole path. I'm sure a lot of you have. So, but yeah. So, I mean, when I explain Elixir to a lot of people, I say, well, what does the world look like? You think it's like, oh, all the languages are the same. You can pretty much solve, you know, anything in any of them, and none of them are inherently safer than others. And you can make bugs in any language or environment. You can do functional programming pretty much in all of these as well, except for Go. But this is another slide from one of my blogs. And it's where I try to explain, you know, what this thread or process isolation in Elixir is all about, or in Erlang. I mean, it's a feature of Erlang, and it's really about the memory here. I had a little info diagram here that this thread or process has its little blue pieces of memory, and this one has orange has its memory, and it's all kind of bunched together in the same place. And I described this first category of languages as, you know, guns don't kill people, people kill people. Meaning, like you've got a gun, and it's loaded, but don't try not to destroy other processes or other threads. It's really your responsibility, and you know, well, if something happens, well, oh well. Anyway, so then there's a bunch of languages, and Rust is in this category. I should have Rust up here and as well. I had put it here before. Very complex, but Rust and Scala Clojure, they adopt a lot of more immutable constructs by default. They might like have Clojure has transactional memory to try to say, yeah, we pass things through a very well-constructed mechanism, which is not going to allow you to accidentally destroy somebody else's memory. So they're what I call responsible gun ownership. They follow rules. They put their guns in a cabinet and they lock them up. You can unlock them and still cause problems, but at least they're not like by default ready to go. And then you get into Elixir where they just said, hey, we don't need shared memory at all. In fact, let's just take those away from you. And you live kind of in a society where you cannot destroy P1 and P2 can't destroy each other. You have isolation. So anyways, this is my fun slide. So just to illustrate what this does for you, you can Google how to kill a thread in Java. All right. If I could see you guys live, I would wait for an answer here, because of course the answer is you cannot. You cannot. So you've got a JBoss server running, and you've got 20 or 30 or 100 threads running, and one of them is stuck. This is actually a question I found on Stack Overflow. One of them's stuck. Actually, and it's a third-party library. It's somebody else's code that you've got running in your JBoss server, and the thread is stuck. What do? I'd like to kill it without restarting my server. Well, the answer is you can't. There's no way to kill a thread in any system that uses shared memory. So Go, Rust, Ruby, Python, all of them, they can't kill threads. Or in Elixir, how do we kill a process? We can actually use brutal kill, which is the exit or the kill in Erlang, and it will take down that process. It'll take down cleanly every piece of memory it uses, and will guarantee you not to screw up with other processes. So this is why you can have a micro monolith, because these are truly isolated services. Why is this important? Keep the system running. You know, having the ability to shut down things that are not going right is keeping things running. Security. You can think about this if you got third-party code and running. You know, it's isolated. It can't even access your memory in another process. So this is good for banking. One more slide, or is it two more? Immutable code. So here's another quiz. This is Ruby. I've got a hash. I do something with this hash. Now I say, what's the output here? If anybody in the audience can tell me what this will print out here or output, they're lying, because they can't. There's no way you can know, because this thing can be manipulated here by this function. So unless you look into this function, you cannot tell me what it does. So of course in Elixir, immutable data means this value is still the same. In fact, I can guarantee it. So it allows me to read code easier. And one last thing is about sequential code. Again, simple code. This is, you know, some JavaScript with callbacks. So I start opening this file. You know, here's my function I handle when the file is open, which means then I'm going to write, and when then the write is done, I'm going to close it. And then there's error handling everywhere. Here's the Elixir code. So this is pretty basic stuff. But maybe one thing that you think about sometimes is like, can you do this? You know, can you do an async await in Elixir? Yeah, you can. You can use task async, which turns something into an asynchronous thing that then you can wait on later. But the point here is not. The point here is that I had something else to do some other work. This is critical. In JavaScript or other languages where you become the scheduler, you're doing this because you want to be nice and break up your tasks, or not hog the thread, or do those types of things. Like you're thinking like, I'm the scheduler. Whereas in Elixir or Erlang, the only reason I would ever make something async is because I have something else to do, not because I want to be nice and give up my thread and let somebody else use it. So. Got any questions yet? Oh, what was there? Oh, and in fact, this construct you won't see too often. We had a few places in our code where we use this, and they're gone completely, because quite often you end up using messaging instead of doing this kind of stuff. And I'll explain that later if I can get to it. I got to keep going here. So Elixir code's easier, simple, easy, blah, blah, blah. So now we get into our experiences. Returning to the example we had, which is the project we did. Again, you can pause it and look through it here. Mobile clients, tablets. This actually has a 2D and a 3D camera. It has a depth camera here as well. So it's actually looking for depth as well. We did a count, you know, of our lines of code. Biometrics backend, we have two big services. One is the biometrics and one is the user backend. So we did some counts, a line count. I guess the interesting thing is we had these two services both came in about, you know, around 10,000 lines of Elixir code. It's not a lot. In fact, the funny thing here is just the package for our just the JSON package dash the JSON package for the assets for the front end, which just tells you what packages are used in the front end, had more lines than all of our Elixir code, which was like, and that's just the you know, nodes, the number of packages it needs. we had an iOS client, an Android client, and also the terminal. And here, one interesting thing is you can see we also have Go in here, and we use Go in a few places on the server, mainly when we had to do 2D image processing, because in Elixir, manipulating or mutating two-dimensional data or 3D or 4D is not really the best type of thing in Elixir. So all that means is that why don't you just run it externally and use all the great tools that Elixir has for managing external processes. So we have this, it's in production. Just some things, the results we had, we've never seen it crash. Actually, Michał, when we started this project and we first set up our dev server, I said, I don't think this thing will crash very often. And he said, no, it's going to crash at least some point in time in the year and a half that we've run it, but it hasn't. Prove me wrong. So internally, it has faults. It had a fault. It's not uncommon. Something goes wrong, but if you design your supervisors correct, it catches it, it shuts things down, it restarts things, and you look at your log files and realize that, gee, something is not working correctly. We need to fix something. So supervisors save your ass. We achieved our goals. Our cost to run is really low. The micro monolith design we have, it scales like really well. It's actually incredible. We ran some numbers, and some of the people we told, they didn't really want to believe us. They were like, well, no, we can connect 5,000 terminals and start doing 150 transactions a second. And they were asking us what kind of cluster, and we were saying, well, we haven't really clustered it yet, because then we could go even bigger. But how do we achieve this? So micro monolith, we actually tried a microservice project, a previous one where I thought, oh, microservices, I'll have to design everything with microservices. And this failed. And one of the reasons this failed, or some of the reasons are, the REST protocol, HTTP and REST, is not really a good protocol for IPC. You have to marshal in and out of JSON. Messages are not guaranteed. You have to retry. They're not ordered. You make changes and you can't find what it affects, and you end up with, it might be good for a very large team, but for a small team trying to do a lot, it's just slowed us down. So in Elixir, we did the micro monoliths, which meant we defined a couple of big services, and really the difference of why we even had two services is we thought one of them is in a different security domain. It has user data, and it might someday be replaced by another system. It has very different scaling requirement. So we separated it into two major pieces. What we found was Elixir is really great. Even parts that we thought, oh, it's not going to work for image processing, that's okay, but it's great for controlling the pipeline. So we say, hey, do this first, take the result of that and pass it to that, configure the pipeline, deal with timeouts, all those things work great. So interoperability with, here we run a lot of Java at the bank. We found that it works great. Our DevOps, we spent some time on the pipeline and setting up where we run our servers. But it's not that different than deploying like a JVM with JBoss or something. It's like a container. So security audit, it was nice feedback from our security auditors, which is a third party, and they said, oh, we don't really know Elixir code. And actually they did. They had done some Erlang before, and they took a look at it and they said, oh, this is great. This is actually the easiest audit we've ever done, because we can see the security so clearly here in the code. The licenses, we also looked at, another team looking at our licenses, and I don't know if you ever deal with this, but like looking at your dependencies, when somebody comes to you and says, I need to know every single library you are using in your project and every license for that. That's like, if you're using something like Node, you might be kind of scratching your head and worried. Problems, not everything was great. I mean, the problems we encountered, I'll just, run some down here. We had some circular dependencies, which was weird. We created a project structure, and then we realized that it was like, oh yeah, this is mostly dependent upon that lower layer, but sometimes it's the other direction. And so we ended up having to break those cycles in order to make a clean project. Some of our gen servers that we made, especially the payment transaction, grew to be really kind of big, and we had to spend some time refactoring those. Phoenix, we had problems with synchronization because now you're dealing with messages and gen servers instead of some of the other things you might use in other languages like mutexes or things like that. You might find a process is not existing anymore. So sometimes all of this concurrent messages, things running around, getting destroyed and created, sometimes you have to go through some log files and spend a few hours drawing sequence diagrams and like, this sent that guy a message and he crashed and then that crashed and then, okay, then he came back up, but then he went down. So it gets kind of complex sometimes. And also, like I already mentioned, not really a problem, but just multidimensional data mutation is not really great for Elixir. So one last thing, just to give you guys some more meat. What we designed a lot of our services around were, modeling the gen servers around some of the core processes. For example, transactions, and this is not a database transaction, but a user transaction. Either a cash register can start a session, or the user can walk up to the terminal and press start, even before we know that a cash transaction is going to start. So these types of things where there's an arrival question, of course, because gen servers are single-threaded, they're like a single point of a transaction, you can sequence things and you can say, okay, the user pressed start before the cash register did start. So it also means, like when we have our recognition session, we said, don't block the session. Because if you block that session, it's single-threaded, you're blocking everything. So this is where, like, if somebody would write this code in your recognition server session, gen server, and it's like waiting, it's like gonna block stuff. So, so it's just some practical advice. It's not Java, so don't try. We had a lot of people come in from Java and like, hey, let's do this. And like, no, don't do that. This is a great book, something that really explains the idea of designing the business, designing the services before you design the database. And I think that's important because sometimes you get it upside down and just design a database that everything's a transaction instead of saying, what is the state I'm modeling? What are the processes that are running here? And when do I actually need to save to a database? I only need to save to the database when I need to be at a point to recover from. So for example, when we're in the middle of a recognition process, if something goes wrong, we don't actually need to recover every step along the way because we're going to roll back to the beginning of the recognition. So, creating lots of extra database transactions doesn't help anything as far as reliability goes. Okay, so just some fun slides. I guess you guys are already, using Elixir, but we always get a kick when the new guy comes over from our Java Enterprise group and says, "Where's the code?" And it's like, it's right there. You're looking at it. Like, no, but like, where's the rest of it? No, it's all there. So yeah, it's there's some of it in the supervisor. You got to look there too. So testing is also interesting because it becomes part of your code, and we discovered that testing is actually something we need to train our developers more on. We actually have to have training sessions on testing because it is so different. Convincing yourself, giving developers some time to understand the fundamentals so they don't get too freaked out about the no loops and data being immutable. Just give them a week or so or two to get used to it. OTP is complex, so it doesn't help for, I think, the Elixir community to say it's the simplest thing to learn, because it's not. It's actually very complex. Freedom is scary. A guy who comes from Ruby or Java or whatever, they're like, oh, I got a directory, which is a namespace, namespace, namespace. Where in Elixir, it's just modules, and you know, you can organize them however you want. So, and refactor continuously. That's what else we found. It's like one of the greatest things in Elixir is being able to refactor all the time, because there's not all of those object-oriented entanglements. So anyways, adopting Elixir in a large organization. Technical merit will help you deliver business value, meaning Elixir is so great, it's going to help, and we all focus on business value, which is important. But you know, the main question comes down to maintenance a lot of times in a large organization. You know, if you go around saying Elixir is different, it doesn't really help people in the organization want to adopt it. So some questions we heard were, you know, well, tell me, is Elixir going up, down, or sideways? You know, in this large organization, your Elixir project might just be a small drop. And it's a valid argument or a valid discussion with a large organization about maintenance, about, you know, can we find engineers? You know, will this survive for decades? What other companies are using it? Is it secure? You know, so these are really valid things in a large organization, and you have to be ready for them, ready for those discussions. So you want to start using Elixir at your company? We say, you know, pick an impossible problem, because nobody will ever ask how are you going to implement it or which language you're going to implement it in, and then succeed greatly, and then discussions will get easier at that point.